another session of the Niger You Drive training, funded by the IHS Stars of Strength and implemented by OVL Foundation and Kratos Sustainability Consults Limited. My name is Abayomi, joining from NESA 84 Labs, and I welcome you on board once more. So today we'll be taking a look at the introduction to machine learning. Okay, in previous sessions, we've taken a look at introduction to Python, Python list, dictionary, variables, data types, control flow, conditional statements and all, control logic, and we can check out the previous sessions for that so as to stay updated on track. So here today, we'll be having a look at what is machine learning. So can anyone tell us what you understand by the term machine learning? What do you understand by machine learning? Anyone able to give their idea? So if you'll be speaking, just tell us your name, where you're joining from, and then you can make your contribution. Hello? Who will go for us? Okay, so let's Winnie, welcome. Let Winnie go for us then, since no one is speaking.
It's like you have already opened it for us now, so we from beyond.
Okay, despite the fact that I've opened it, what do you understand it to be? Might not necessarily be what I have on my screen here. It's intentional. I did that. Okay, since no one is going, let me just proceed then. Okay, so when we talk about machine learning now, you have two words coming together. You have the machine and then the learning aspect. All right. Who wants to go for us? Okay, Winnie. All right, you can proceed,
Okay.
Winnie.
Good evening, everyone. Apologies
Good
for
evening.
any distraction. I'm still on my way though. So I just want to try regarding what I learned this morning.
Okay.
Can you hear me?
Yes, we can hear you.
Okay. So for machine language, what I understood, I feel is used to build predictive models, like models from data, and after collecting, cleaning, and analyzing data science often use the machine language to extract insights and make forecasts or automated decision making. Yes.
All right. Thank you very much, Winnie. That's a very good one. Okay. So machine learning, as I was mentioning earlier, you have two words here, machine and learning. Okay. So that means, as Winnie said, there is an existing data that has been given to a program to learn from, such that based on what it has learned over time, okay, studying the trends and patterns and all from that data, you can be able to make wise decisions. Make predictions for the future. Okay, so machine learning is a branch of AI, which is artificial intelligence that allows computers to learn from data, and you make your decisions without being explicitly programmed. So you give your data to the computer, you give it to a program to learn from, and from there you can just say, okay, based on this previous data you've learned from, what can you say is going to happen based on these certain conditions I have? So instead of following our fixed rules, machine learning systems improve their performance over time by analyzing data and identifying patterns. Okay, so a very good example is, these days we're always clamoring about, oh, there is global warming, and all this is due to what? The variations we have concerning the environmental conditions, right? So even taking a look at before you step out in the morning, you take a look at your weather app on your mobile device, it's going to give you a prediction that, oh, at so time, there is going to be what?
Either rain or the sun.
Sorry, we can't hear you again. Am I the only one that can hear you?
Make sure you go out with your
I
umbrella.
can
I think his network is bad. Let's just give him a few minutes, please.
You can hear me now.
Yes, we can hear you.
Yes.
But your
Okay.
screen is not
All right. So how about now? Can you hear me now? Please, someone should just confirm if they can hear me.
Yes,
Yes, we
Hello.
can hear you. Yes. We can hear you. We can hear you, sir.
Okay. Thank you. Okay. All right. So I mentioned considering the weather application. So let me pick up from there. This might have been a little gap. So considering the weather app you have on your mobile device, giving you pre-informed, helping you to make decisions concerning the time there's going to be a rain or there's going to be a shower. Okay. So over time, that data is being collated and the machine learning systems understand them, they analyze the patterns that occur based on that data. So when it comes to machine learning, we have three types of machine learning. Okay, so one is the supervised learning. All right, so when we talk about supervised learning, that means you have what we call labeled data such as it has column names. Let me put it that way. Now we are talking about structured data sets for supervised learning. So it has a column name such that you can say, okay, for instance, when you are taking data concerning a person right now, their first name, last name, middle name, their age, their address. Okay, so you can say, okay, you want to predict maybe their body mass index, depending on what you want to predict. However, this supervised machine learning is divided into two parts. We have the first one, which is the regression. So when it comes to regression, it means you want to make predictions. Your output is going to be based on continuous values. Continuous values in terms of sales price. Say, that is what's continuous. Say, for instance, you got a particular item, maybe 20 naira about 10 years ago. In another 5 years' time, it became 15 naira. In another 5 years again, it became 20 naira. You see that like every 5 years, there's a difference of 5 naira. So such target variable right now, the sales price is continuous, such that it's just values, and values. Okay. And then the other one is the classification. So when it comes to classification, you are trying to predict categorical variables in the sense that you want to predict, say, true or false, maybe yes or no. For instance, you might say, okay, based on certain parameters or certain features, is this person living in urban area or they are living in rural areas? Okay, so you want to predict if a person resides in a particular location, be it urban or rural. So that way you have what we call categorical variables, which are discrete.
I don't think I can hear you. I don't know if you hear me.
I can't.
Same here.
Excuse me. But
Hello, everyone. Hello.
hello. Good evening.
Yeah.
I can hear you now.
Okay, can someone confirm if they can hear me now?
Yes, can hear you from my own end.
Okay. All right. I think the network is really acting up. I tried switching to another ISP, so let's see how this works. Okay. So can I know where I was lost? Can someone just so I can continue from there?
We're talking about the supervised learning.
Supervised data learning.
Okay, all right. Thank you very much. So when it comes to supervised learning, the algorithm, I mean, your models that you're going to build, your program is going to learn from labeled data. That is, you already have a feature and output in mind that you want to predict based on some certain features. And for regression, it deals with predicting continuous outputs, continuous numerical outputs. While for classification deals with predicting categorical labels, I mean outputs. Okay. So examples include predicting house prices, which is an example of regression. While for classifying emails as spam or not, we want to say, okay, is this email spam? If true, take it to the spam folder. Else, move it to your inbox or your update or your promotions tab, depending on how you set up your email system. And we have common algorithms used for supervised learning. They include linear regression. So linear regression is used for regression itself, while for the logistic regression is used for classification task. So let's have this. Linear regression used for regression, while logistic regression is used for classification. Then we have the decision trees. We have support vector machines. Okay, so decision trees and support vector machines, SVM, they have their variants. You have the decision tree regressor, you have the decision tree classifier, you have SVM regressor and SVM classifier. Okay, so when we work further, you'll be able to understand this more and more. Then moving to the next type of machine learning is the unsupervised learning. Okay, so when it comes to unsupervised learning, the algorithm, the model you will be building will learn from unlabeled data. So the algorithm itself will try and walk through the data. There's no label, there's no output you are trying to predict in this space right now for unsupervised learning. So there's no labeled output. So the algorithm is going to learn from the unlabeled data and is going to begin to discover certain features, certain patterns, certain trends within the data set. And then it's going to give you your results. So an example is the clustering algorithm. So what the clustering algorithm does is, I'm sure we've heard of this concept used in agriculture, and when they talk about a farm cluster or a cluster settlement, it's just like you having some particular group of persons being bounded together. You have another particular group in another location, then you have another particular group. Okay, so when it comes to that, clustering is simply means you grouping data points based on similarity. Okay, so for instance, Nigeria, we have the three major tribes right now. We have the Igbo, Hausa, and Yoruba. Okay, so if you even take a look at the map of Nigeria, you see that a particular side is tagged, oh, this is the southwest. Another particular area, I mean, based on geographical locations right now, you see, okay, this is northern Nigeria, this is the southeast, based on the regions that way. So that is also what the clustering does. It tries to group your data points based on the similarity, based on the features. So an instance is a customer segmentation. Okay, so you try to look at it, okay, this type of person, say for instance, you are looking at telecom data right now. Oh, kind of persons from this particular location, they recharge so amount. Okay, we can group them maybe or as a high net worth individual. Okay, then you have your customers. Based on that, that is how clustering works. And when it comes to dimensionality reduction now, okay, so this helps you to reduce your data complexity. And even in cases whereby you are working with large tons of data sets, okay, you can also make use of this dimensionality reduction aspect for you to be able to reduce the features you are working with, such that only the important features, the features that will contribute meaningfully to your project, would be extracted for you. Okay, so and when it comes to unsupervised learning, basic examples of models, okay, an instance is customer segmentation, market basket analysis, and the algorithms include the k-means clustering, hierarchical clustering, and principal component analysis. So I want you to know that there are more to these models. Okay, so these are just the common algorithms we are sharing with you. And another type of machine learning is the reinforcement learning. Okay, so when it comes to reinforcement learning, you are trying to give the algorithm full space, okay, such that, okay, you have this particular issue. I want you to interact with it very well. Okay, so based on trial and error, the machine will check, oh, did he get it right at this time? It's going to store that to memory, go through another route again, store that to memory until a perfect result is being achieved. So that's why we said for reinforcement learning, the algorithm learns by interacting with an environment to maximize cumulative reward through trial and error method. And examples include game playing, chess, whereby you just allow the algorithm, okay, computer plays it this way, then it learns that, oh, this is the right way to play. So over time, it gets into the memory of the model, and it's able to give you more efficient results. Instances include in robotics and recommendation systems. So algorithms include Q-learning and deep Q networks. Okay, so for the scope of this class, we wouldn't be going too deep. We'll be considering the supervised learning. Okay. All right, now, so moving on, we have the machine learning libraries. So apparently, what are machine learning libraries? Okay, I'm sure in previous classes, we've delved into modules and packages, which include the pandas, where we use for data wrangling, and for NumPy, numerical computation, that we used to perform a numerical computation and analysis. Okay, so you could see that those algorithms have been built already. So you do not need to start coding and saying, oh, I want you to predict this. How do you get this done for me? All right. So part of the model we are going to explore today is the scikit-learn library. Okay, so scikit-learn. So like I always emphasize, it is very important to learn about this libraries. Okay, so let me just put it on Google and say, oh, scikit-learn, and let's see. All right, so you can see scikit-learn is a computer program. It's free and it's open source. Okay, so it's a free library you can just plug into and make use of, and it's open source. Open source in the sense that there are a lot of contributions going on across the globe. Okay, so you as well, you can be a contributor. How do you contribute? That's not difficult. You can use the model and say, oh, I tried solving a particular problem with this library, and this is what it gave me. Okay, you can say, oh, you want to go through the documentation and also improve more on the documentation. So that is how you contribute. It doesn't have to be something very big to do before you also make your contributions. Okay, so this is a scikit-learn. Let's check in through the documentation page. So you can see here they said scikit-learn is is used for machine learning, and it's built on Python, and it's simple and efficient tool for predictive data analysis. It's quite accessible to everyone, and you can reuse it in any context you want. It's built on NumPy, SciPy, and Matplotlib. And it's open source and commercially usable. All right. So you can see, we mentioned earlier on, you can use scikit-learn for your classification task. For instance, you want to identify which category an object belongs to. So in case you want to say, oh, is it belonging to group A or group B or group C? Okay. Then for regression, is used in predicting continuous valued attributes associated with an object. So you want to predict your stock prices, you want to predict sales amounts, maybe you want to predict salary as well. You know, that's a continuous value. You can make use of the regression model. And for clustering now, all right, you can see for automatic grouping of similar objects into sets. So you can see, for instance, based on this picture we have here. Oh, that didn't get through. Let me just go back. Okay, so based on this project, you have picture we have here right now, you can see some certain objects moving into a particular group. You can see this is red, blue, and whole. So you can see where you have this X, that's the centroid. You learn more about that later, okay? That is not within our scope here. So for dimensionality reduction, you can use scikit-learn. When it comes to your model selection as well, when you want to do data pre-processing, when it comes to feature extraction and normalization, or say for instance, you have your data in as categorical variables right now, and note your computer does not understand categorical variables such as text and all, so it only understands numeric, I mean zeros and one programming language. So you need to use this library to convert your text, I mean your object data type, into what? Into numeric data type. That is the integer or the float, depending on the scope. Okay, so you can see concerning the news for scikit-learn, it said, oh, scikit-learn version 1.7.1 is now available for download. This is as of July 2025. You can see ongoing development, scikit-learn 1.8. So you can see much is being done on this library. And the community, you have questions, you need to ask one or two, you want to support the project as well, you can always reach out to them. Okay, so now we've learned about scikit-learn. How do we make use of it? The first thing first is you come to the installation area. Okay, so you can see installing scikit-learn. There are different ways to install scikit-learn. So before you make use of a programming language, you need to first of all have it installed on your computer, okay, on your local environment. All right, so now we can see we have different types of operating system. We have Windows, Mac OS, and Linux, depending on your machine. And we have the package manager. Is it pip or conda that you want to use? So you can go through this and learn more on it. Okay, so these are also the dependencies. Recall they said scikit-learn was built on NumPy, SciPy, and Matplotlib in the first page we checked. So these are dependencies that scikit-learn was being built on. Okay, so we can always read this later on. Let's get back into the business of the day. All right, so we've learned about scikit-learn. It consists of general machine learning models, and for pandas, it is used for data wrangling. I mean, use it for data manipulation. For NumPy, use it for mathematical operations. Then Matplotlib and Seaborn is used for your data visualization. Okay, so first thing first, welcome to the Jupyter Notebook environment. So before we move on, do we have questions? Okay, welcome, my chief. Our tutor is here. Welcome, Mr. EGK. It's great having you here this evening. Do we have any questions before we proceed?
Thank you, sir. Thank you, sir.
Welcome, Chief. Do we have any questions before we proceed? Or am I performing magic, or I'm too fast? I need feedback. Or do we call it an evening? Hello? Please unmute and speak.
I don't have questions.
Okay, you do not have any question. All right. Okay. Okay, thank you very much. Thank you very much, Winnie. Let's move on. Come to speed. Okay, so first thing first, we need to install our scikit-learn library. So we'll be using the pip manager. So we'll run pip install scikit-learn. Please note something here. Here we add what? Pip install scikit-learn. Okay, so I'll run this. And it says, oh, requirement already satisfied. Scikit-learn is already installed. And the version I have installed here is 1.6.1. Okay, so that's still cool and fair. So 1.6.1 was, when was that released? Okay, so you can see the version still available on Google Colab was released in January 2025. Okay, so let's proceed. So that's already done. So in case you want to show the sklearn library, how do you import it now? So, you know, after installing your library, when you want to make use of it, you need to import it. So how do you do the importation? You say import sklearn, and you say sklearn.show versions. On running this, you would have the current system we are making use of is a Python 3.11.13 environment, and we are using a Linux machine. This is Google Colab. And the dependencies include sklearn, pip, setup tools, numpy, scipy, Cython, and a whole lot of them. So don't be considering all this. However, so when it comes to you doing machine learning, it is very, very important that before you dive into a project, you have a very good understanding of the business. Okay, what's the problem you're trying to solve? What are the minimum requirements from your stakeholders that your stakeholders expect you to give an answer to? Okay, so having understand the business, then what type of data do you need to solve that task? So say for instance, you want to deal with there's this popular word, okay, let me not use that, you know, banking the unbanked that they use in finance. I mean, on the social space, banking the unbanked. What does it mean? That means you want to create a solution such that even people in remote areas can have access to banking facilities and all. Okay, so you understand, you need to have a very good understanding about finance, how money moves and all. Then what type of data do you need to collect? So say for instance, you want to bank the unbanked in rural areas right now. You need to understand what those people are into, what's the demographics of the population in that particular region. Okay, so that might include their name, you know, their age, their educational qualifications, their literacy level as well. Okay, so having understood the data, then you need to prepare the data. So most times, data does not come in the proper format that you need it. Okay, you need to do some fine tuning, which include cleaning, transformations, and all. All right, so after you've prepared the data, then it's ready and fine. Then note that when it comes to machine learning, machine doesn't understand categorical variables. You need to what? Convert it. You need to transform it using libraries such as Label Encoder, one-hot encoding, and all. Then you make it ready for your modeling, whereby you pass it into the algorithms then you begin to evaluate it that, okay, are we getting a good and accurate result? If yes, then you proceed. Otherwise, you still have to go back to the data preparation stage. You model it, you get it in the right shape again, you model it again, then you evaluate until you get desired answer. So there is much and much of iteration. So as you can see here, you can see the process keeps flowing. So after your evaluation, you still check, does it meet the minimum business requirements? If no, then you still go through the loop again. And if yes, after it has passed certain checks and you see that, okay, this model is fit for use, then you deploy. And you notice, for instance, like this scikit-learn now, you can see the trend. Over time, they've been working and making improvements on it. So it's not just for you to just build a model at a particular time. You need to always go back in time, revise it, add more data, let it learn from the new trends and all, so that it will give you an accurate predictions. Okay, I'm sure many of us would be amazed when we visit the market. Say, for instance, we got a particular item, like say maybe 5 years ago. Okay, then we want to go to the market right now and you want to purchase that same item. Due to inflation, you might just hear that, oh, the value has now increased from 100 naira to 1,000, and you'll be like, wow, how did this come to be? Because of what? You do not get that particular product frequently. So, and when you get into the market, you just got to know that, oh, this thing is now 1,000. Okay, so that's what also happens with our data as well. You need to keep refining. So this is the cross-industry standard process for data mining. So have a good understanding of the data, of the business, then understand the type of data you want to work with, prepare the data, put it in the right shape, in the right format, you model, you evaluate, and then you deploy. So I'm sure many might be asking, oh, this deployment phase, I need to put it on the cloud, make it accessible to my users. Most times, your users might need to interact with your solution. And oftentimes as well, it will aid your stakeholders in making the right decision. So depending on the end, that will justify where you're going to deploy your project to. All right, so the machine learning pipeline or workflow, how do you get to do your ML? Now we are moving into it gradually. So first thing first, you collect your data. After you've had a very good business understanding, data collection follows. Then after that, you clean your data. Cleaning, at this stage, you spend approximately 80% of your time cleaning data, because garbage in, garbage out. A clean data will give you excellent results. And if otherwise, the end game. So you look out for missing values, you try to treat them very well. There are different methods to treat missing values based on the project scope. Then you remove noise in terms of, say, outlier. So for instance, you are trying to study, say you got student data from a university, or say for instance a primary school right now, and you are seeing in one of the rows, you are seeing the age 120 as the age of a primary school student. Would you leave that 100 to be there when others are within the range of, say, 5 to like 10 years? So that 100 is a noise in that data. So you need to what? Clean it up. Otherwise, it will surely affect whatsoever you are doing later on. Then after you've cleaned the data, it's in the right shape, it's in the right format, you've transformed your categorical variables into numeric, then you split the data. That is where we come to the point of the train set and the test set. So the train set is the data you're going to give to the algorithm to learn from. Okay, so in most cases, we do like 70% or 80% is used for training the data. Okay, or for training the algorithm rather. Okay, so after that, once the algorithm has learned from that 80% data set now, then the remaining 20%, it has to be a whole of 100%. The remaining 20% you give to the algorithm that has learned from that previous data and tell it that, okay, predict this, and then you proceed with what? Your model evaluation that way. So after splitting the data sets, you go ahead to choose your model. So the type of model you use is based on the project at hand. Is it a regression problem? You want to predict continuous values, or a classification problem where you want to predict discrete outputs? Then you bring in your algorithms here. Then you train the model. You do what we call model evaluation. Check out the performance of the model. And from there, you tune the model parameters. So, for instance, you are using default parameters to evaluate the problem statement. You might need to bring in other parameters, such as increasing the value of your train set. I mean, maybe you want to reduce it or add more data sets. You might say, okay, you want to increase the depth of the trees if you're using decision tree models. So that really works with what? Tuning, parameter tuning. And then you proceed again to predict on your new data. So all these are the steps you need to follow through: data collection, data cleaning, data splitting, model selection, training and evaluation, parameter tuning, and then prediction. Then common models we would use: logistic regression is used to predict category, while linear is used to predict continuous numbers. Then decision trees models are easy to understand and a good starting point. You also have the random forest, which is a powerful version of decision trees. That is, multiple decision trees together make random forest. Then you also have the KNN, which is the K nearest neighbor. Okay, so it looks around and say, oh, who are my neighbors around here, and tries to bring them together and work with it. So it's simple and it works with small data. Okay, so you might want to ask the following basic concepts: what is a model? What is training? What is prediction? What is the loss function? And what is the gradient descent? So these are really cool and self-explanatory. All right, so we'll be exploring before we proceed. Anyone with questions or comments? Anyone with questions or comments? Okay, no questions from Makinde. Okay. All right, so I believe we are good to go. All right, so let's move on. Let me share my screen then. Okay, so now we want to take a look at how do we work with linear regression, that is a supervised learning task. So now, for instance, you want to predict house price. So you can see here we have a data set. We have the size in square feet, and we also have the price in thousands of dollars. Okay, so you can see for a house of 100 feet square, you have the price to be 300,000 USD. A house of 1,500, $400,000, then 2,000 feet square. You can see the amount here. So we know in our mathematics, when you want to do your graph plots, when you want to find the slope, okay? How many of us recall this formula? Y equals to mx plus c. Can I see your hands up? Y equals to mx plus c. let me just proceed. So here you have your price, you say equals to M multiplied by the size plus B. So where the M is the value of your slope, because when you have like your graph, you have the y-axis, you have the x-axis, and you try to plot a linear line, having picked the point of the intersect of where your x and y values, where they intersect together, and then you try to plot a line graph, you try to find the slope. Okay, so the algorithm is also going to look out for the slope for you. So for linear regression, we find the best values for the slope, which is M, and the intercept, which is B. That minimize the error between the predicted and the actual prices. So this has to do with more of the model evaluation now. You've already trained 80% of the data with your algorithm, and then you want to test on the remaining 20%. Note that 20% has actual prices, but now the one that the machine is going to predict. So you need to compare between both. Okay, so that is what this line is explaining. All right. So I don't want us to move into this. We'll take a look at this soon. All right. So first thing first, when it comes to supervised learning, we'll be taking a look at this regression task. And for you to move on, first thing first, you need to do what? Ensure that your libraries are installed. So we'll be making use of the pandas package, NumPy, scikit-learn, and matplotlib. So pandas here is used for what? Data manipulation. NumPy, numerical programming, scikit-learn, a machine learning library for our regression task. And then we have a matplotlib, which is used for visualization. So I'll be running these code blocks now. So you can see pandas is already installed. NumPy, let's see, it says it's already satisfied, it's installed as well. Okay. All right, so these resources has been shared on the group chat earlier on, so you can also make a clone, make a copy on your hard drive and work with it. So here we've actually run pandas, we've installed NumPy, scikit-learn, matplotlib. Okay, so having installed them on our computer now, next thing is for us to import our libraries, our packages. So import pandas as PD. I'm sure this is understood by now. Import your package, then you give it an alias as PD. That is, you don't want to be calling pandas in full every time any longer. You do NumPy, then you bring up matplotlib. Now, here, while we're installing scikit-learn, you can see we have scikit-learn. Okay, but when you want to import it, you say from sk.learn. All right, so to install, you do scikit-learn, right? However, to import, you import as sklearn. So let this please take note of this. Okay, it's very, very important. So you say, okay, from sklearn.model selection, I want you to import train test split. So what this train test split does is it's used for splitting your data sets. Okay. And then we have the next algorithm, which is sklearn.linear model import linear regression. All right, so this is the model we want to make use of. So if I should order over on this linear regression, or you can see ordinary list, squares, linear regression. Linear regression fits a linear model. So you can also read up the documentation of these models online to see how you can use them, how you implement them, and how you can also check out the parameters that they require. Okay. All right. So do we have a question or a comment? All right, I think I can proceed. Okay, so now having imported our packages, so let me run this clear this over and run it. So now this has been run to memory. I've imported my packages now. I need to bring up the file. So we'll be working with the housing data file that we've been working with earlier on. So that has been shared on WhatsApp chat. So in case you need the data sets or you do not have a copy, just let me know so I can reshare on the chat. So I've mounted the data already on my Google Drive here. So housing.csv. So please note, any data set you mount here, once the runtime has expired, you wouldn't be able to find it here any longer. Okay. However, you can always add files via your Google Drive. So you mount your Google Drive, you connect to the Google Drive. So your Google Drive will be your storage. So even when the runtime expires and you come back again, you can always run it, and then the data will be picked from your Google Drive. So how do you import to this runtime environment? Just click on this upload to session storage here. So once you click on it, you have a file explorer window that comes up. Then you navigate to where you have the data, then you upload. It will be here. Okay, so first thing first, I want to ingest my data. I'll call the file path. Okay, that is where is my data stored. You make a reference. Then now we are using pandas. Okay, so load data sets using pandas. Right, so you say df equals to pd.read_csv, then you do your file path in parentheses. So can someone tell me why we have read_csv here and not read underscore any other thing again? Can someone tell me? Hello. Hello. Hello.
We can hear you, sir.
Yes, I'm asking a question so we can move forward. Okay, all right. Cynthia says I'm importing a CSV file. All right, thank you very much. So because I'm importing a CSV file, that's why I had to use read_csv. So there's actually a lot of them. So let me say, for instance, I say pd.read. Okay, so this might not bring it up. Okay, so it's here now. Read underscore, you can see I have a whole lot. I have underscore CSV, I have underscore Excel, Fedder, HTML, JSON, Parquet, Pico, SPSS, SQL query, and all. Okay, so but here now I'm importing a CSV file. You can see my data file here. The extension here is .csv. That's why I have to use this. Then I say call the first 5 rows, which you use df.head. So the default is 5. So if I should change the n to something else, you would see maybe I say n equals to 10. It's going to print the first top 10. So let's run this to memory. So this is our data set. Consists of data such as the price, and then down to our furnishing status here. Okay, so let's take a look at our data. How do we get to understand this data? How many columns do we have? How many rows of data sets? How many are numeric values? How many of the features are categorical or object as the object data type? So we'll do df.info. Okay, so on running this, all right, this is a cool data. We have 545 entries and 13 columns. Okay, so our data type, 6 are integers and 7 are strings or have the object data type. I mean they are text. Okay, so as you can see, main road, guest room, basement, hot water heating, air conditioning, pref area, and furnishing status. Okay, so those are the 7 categorical variables. All right, so let's take a look. So our shape has already been done here. So we have 545 entries already, 13 columns. And here you could see it says 545 non-null. So that means our data set is actually what? Complete. So we do not need to treat for missing values, on this data set. Okay, so at this stage now, we'll be working with the numeric columns only. Okay, the reason being that ML algorithms, like I mentioned earlier, they understand numbers, understand zeros and ones, not your text, yes, no, hello, welcome, and all. So those ones, you need to convert them to a language that the machine can understand. Okay, so for the scope of our work this evening, we are going to be extracting the numeric values to work with for linear regression. Recall, our task is what? Linear. Our task is on what? Is on regression. Okay, so regression task under supervised learning. So we want to predict continuous variables. Okay, and we have many of them here. We have price, area, bedroom, bathroom, and all. Okay, so how do we select our numerical variables right now? How do we have a subset of our data such that it's only showing us numerical data sets? So first thing first, you call your variable, you name it numeric columns equals to list, and then you have your df.select data type. So you'll be selecting the data type, which is a numeric, as well as the columns. And then let me run this to memory. So you can see those columns are what? They are price, area, bedrooms, bathrooms, stories, and parking. So having selected that, then you try and create a subset again. So here is to select, then you extract that numeric column from the original data set. Extract the numeric features from the existing, or we call it original data set. Okay, so having done that, you can see we have only price, area, just like what we did here right now. Okay, so now we have our numeric data set. Then we have we want to proceed to the data set splitting right now. So you have what you call your x variable and you have your y variable. So your x variables are what we call the dependent variables. Okay, and then we have the independent. Sorry, the x are your independent, while your y is your dependent. X is independent, y is dependent. Or you can also call them explanatory as your x, and then your y is your target variable. That is, what do you want to predict? What are you targeting at? So we have our features here. So we want to predict the price based on all these features. So you can say, oh, for instance, I have an area that is worth 9,960 feet square. The number of bedrooms there is 3. The number of bathrooms is 2. Stories is 2. And then it has 2 parking lots. What is going to be the price? So that is what we want to work on now. So first thing first, we'll need to now separate the features. So how do you do that? Here already, this is our data set now that we want to work with. You write your variables and say, oh, your features equals to data.drop. So here we are making use of pandas for data wrangling. So we want to drop this price column, and we want only this remaining 1, 2, 3, 4, 5 features only. I say your axis equals to 1. So 1 here means it's a column. If you are doing 0, that means you are working row wise. Okay. So on running this now, you can see what we have now. We have area, bedroom, bathroom, stories, and parking only as our features. Then our target variable y is going to be, you just call your data and then price only. So you can see we've actually splitted the data set right now into the x and the y, which is our target variable. Okay, so you can see we have to rename here. Our x equals to our features and our y is our target variable. Now we have our x, we have our y that our machine is going to understand. How do we get to split the data set vertically? We want to split our data set now such that we'll be able to work with it. All right, so here right now we have this function. We say we want to have the train test split. We said 80% of our data is going to be used for training, while 20% is going to be used for testing. Okay, so 20% can also be written as what? 0.2, and 80% can also be written as what? 0.8. Okay, depending on how you want to put it. All right, so we'd say, okay, we have our x standing alone. And recall earlier on, I mentioned to us that would have what? We need to train the algorithm. Then after training, then we'll now predict based on the test sets. Okay, we have our x, so we have our features now. We would have x train and then we would have x test. So we do not want to do this division manually. We want an algorithm to do that for us. Okay, so we'd say, oh, we have x train, comma x test. We have comma y train and y test. Okay, we want to split it based on our existing features and targets that we already made up here. So we import this library called train test split. Earlier on here, we already imported it. Let me show you here. So here, this is it. From sklearn.model selection, import train test split. So it's going to do it for us automatically such that it will split the data set based on the requirements that we are giving to it. So here we will say we want to use 20% for our test size. Okay, so call x is our target, our feature, y is our target, and then the test size. What we want you to use for testing is 0.2. That is 0.2 of 545 will come to y test. Okay, and then 0.2%, 20% of the entire data set will also come to S test, and 80% will be splitted for those running the training. Then we'll say, oh, our random state equals to 42. So do not bother about this right now. Once you proceed, you learn more why the random state is always set to 42, and you can always give your values even as you proceed. Now let's run this to memory. So yeah, let's take a look at our X train shape and our X test shape. Okay, so it says our X train shape is 436 rows, and then test shape is 109 rows. So let's try and see if we can confirm that. We call our original data set. What was the shape? 545, right? 545. So let's perform calculations ourselves. If you say so, original row, right? Original row is equals to what? 545. So let's now say our x test so equals to your original rows, that is multiplied by 80%, right? That is 0.8. What does x underscore test gives you? What will be the value? You can see it gave us what? 436. Sorry, this ought to be train, not test. So okay, test is 20%. So let's run for that right now. You can see 109. So that's what we have for our test right here. So this module helps us to what? Split our data set based on what we give to it. So if we should say, okay, we want our test size to be, say, 30% right now. We want to test our data set on 30, using 30% of your original data set. So if I should run this in memory and say, okay, 30% is test size, you can see this is 163. Let me run this again to confirm. You can see this is 163.5. So approximately it's 164 over here. Okay, rounding up. So let me replay and return this back to 0.2. So I hope we all got how this train test splits, the work is doing right now. So we don't need to start saying, oh, multiply by 20% before you do this. Actually, you can decide to code that out yourself. However, for efficiency and reasons, so you need to just use the algorithms to make your work faster. So let's take for Y train and our Y shape. So you can see our X train is 381. So also our Y train is what? 381. X test is 164. I'm not thinking I run this back to memory. Okay. So we have it on based on 20% of data now. 436, 5, 109, 436. Okay, so now we've splitted our data sets. The next thing to do is proceed to select our model. Okay, so we mentioned that our problem statement is actually what? It's a regression-based task, and we need to look out for regression algorithms you can work with. We have linear regression, lasso and ridge regression, decision tree regressor, random forest regressor, support vector machine regressor, and all. So we'll be looking at linear regression. So how do you select the linear regression algorithm? So first thing first, I'm bringing you back to the importation so you can see from sklearn.linear_model, import linear regression. You'll notice how they wrote it here, linear regression. So going back here, you can see we call, name of our model, our variable name for the model is going to be linear regression. Okay, so here we'll be making use of the default parameters. And that's why it has a whole lot of parameters. You can see fit intercept, copy, end jobs, positive, a whole number of them. But we'll be working with the default parameters right now. Just leave it this way. You run this to memory. Then next thing, after you've imported your model, you've hold it up. What you need to do now is you need to train the model based on your training data. So here we have the linear regression dot fit. You want to fit it to your training data, X train and Y train. That is, I want you to take each row of this data set, understand how area, bedroom, bathrooms, stories, and parking, how these feature, how they actually influence this particular price. So it's going to learn through that. I mean, this stage that we are currently on right now. After it has learned from it, you can see, give an output, linear regression, it says it's fitted now. So if you want to see documentation, you can open that later on. So now the model has learned from our training data sets. Next thing is, okay, now you've learned, I want you to make predictions for our Y variable based on our X test. Recall now I mentioned that what our X train and X test is already what? Is already available to us. So we train the model on 80% of the data. So we allow the model to see 80% of the data, understand the patterns, everything that is happening under the hood. Now we want to use it to what? To predict based on our X test. I mean, the test sample for our data set that has actual values for Y as well. So you say, oh, Y pred equals to, you call your regression model that you fitted earlier. You say, okay, I want to use it to make predictions on this X test. Then let's see what we have here for Y pred. So you can see based on the X test now, these are the values it's giving. Okay, for our Y predictions. All right, so let's take a look at our Y test. Okay, so our first Y test here is 400. This is 4,060,000. So the first value here is predicting is what? 6,178,670,627.50, etc., etc. So we can always look into this later and see, oh, did this model actually predict the right thing or it gave the wrong thing? Okay. So this is our Y test. This one, the model hasn't learned from it at all. It hasn't seen it. Okay. Then let's convert our Y pred to a data frame. Let's see what we have. So you can see we have a 6.17, that's just over 6. That's over 6 million. Okay. And what we are having here, you can see it's not resembling what we have. So, but later on, we'll have to bring them together and see how they work with together. So next class will be working on the model evaluation phase. So this evening we've been able to take a cue at machine learning, intro to machine learning, the types of machine learning, supervised learning that deals with regression and classification tasks. We have the unsupervised learning where the computer tends to learn from unlabeled data. And we have the reinforcement learning as well. We took a look at the cross industry standard process for data mining, business understanding, data understanding, data preparation stage, how you model, evaluate, and you deploy. And we eventually landed up running a machine learning task for a regression task. Okay, so we into the stage of the model. Hello, do we have questions? I believe our silence here means we do not have any questions. Please confirm if I'm wrong. Please, I need feedback, be it chat, be it voice.
For me, I would like to go over the video again, then before I can come up with questions, if there's any area that is not clear.
All right, so no issues about that. All right, so thank you very much. A very big thank you to you all for joining the session. So we'll meet in the next class, okay, which will be happening on Wednesday. We'll have the morning session and the evening session as well. Okay, so let me check the chat. Okay, you might need to go through the lessons first. Okay. All right, so a very big thank you to each and every one of you for joining. Let me stop recording.